In problem number 4, the sine and cosine curves intersect infinitely many times, bounding regions of equal areas. Find the area of one of these regions. Now, in this problem, we have f of x equals sine x and g of x equals cosine x. And the graph of sine x is the blue one, and for the cosine x, that's the green one. And we're going to find the area bounded by these two curves, which is the shaded region. Or we can also use the other part, but we chose to deal with the shaded part. However, they will have the same areas as stated in the problem. So in this case, for us to solve for the area of the given region, we need to identify the intersections of the two curves. So these are the points of intersection, the one with red. Okay, so for us to identify the point of intersection of these two curves, now we knew that f of x is equal to g of x, which means that sine x is equal to cosine x. Okay, so which means what would be the value of or values of x such that sine x and cosine x will be equal. So in this case, we could use the unit circle, or we could sketch the graph of sine x and cosine x to solve for the problem. Or we can also divide both sides by cosine x. Cosine x. So this becomes sine x over cosine x is equal to 1. Now here, we could simplify sine x over cosine x, which could be expressed in terms of tangent x equals 1. Okay, now the problem here is what are the values of x such that tangent x is equal to 1. Now, the values of x here is 45 degrees, of course. So that's pi over 4, okay? And, or if we're going to use the coordinate plane, that's, oh, sorry, that's here. Let me erase. That's here and here to make it 1. That's 45 degrees and 45 degrees, or pi over 4. And since it's pi over 4, so we have this angle is equivalent to 180 minus pi over 4. That's, oh, this is negative 1. So we're going to consider this to make it positive 1. So this becomes pi plus pi over 4. That's pi over 4. Okay? Or we could also use the graph of tangent, the behavior of the tangent graph. That's pi over 2, 3 pi over 2, and these are the asymptotes. Okay. All right, and this is pi, and this is pi over 4. This is pi, so the graph will look like this and look like this, something like that. And if this is 1, now the point here should be this and this. Okay, we're talking about the 1. Okay, tangent 1. Tangent x equals 1. So the value of x here is pi over 4, right? Pi over 4. And the other one is, that's 5 pi over 4. Okay, so let's go back. So we already identified that the points here, okay, the point here is pi over 4 and here that's oops, let me erase, that's 5 pi over 4. Okay, so this is equal to what? It's, if it's pi over 4, what is sine pi over 4? Sine pi over 4 is equal to what? Mm-hmm. So square root of 2 over 2, right? Square root of 2 over 2. Okay. If I'm not mistaken. Okay, so let's simplify. Let's solve that here for us to make sure. Sine pi over 4. So if we have a unit circle, pi over 4, these are equal. So ones, okay, square root of 2, square root of 2, this is 2. So we have sine opposite over hypotenuse, square root of 2 over 2. So square root of 2 over 2, okay? So we have square root of 2 over 2. And this one is pi over 4. That's what? Sine pi over 4, that's on the third quadrant. So let's solve it again. 5 pi over 4, that's here. These are equal. 5 pi over 4, so negative. Hypotenuse, it's square root of 2 over 2. Correct? Square root of 2 over 2. If this is square root of 2, this is 2. This is square root of 2, negative, negative. Yeah, this is negative square root of 2. So this is negative square root of 2 over 2. Okay, so we are now ready to get the integral of this, or get the area, measure of the area by, okay, using the rectangular strips. All right, rectangular strips, and we're like this. Okay, so again, let's label the parts. This is our delta x, this is our height, okay? And our height, or the length, is equal to the difference of the upper and the lower. So the upper is the blue one, that's sine x minus cosine x, correct? So upper, the blue is sine, or this equal to f of x minus g of x. That's the length. Okay, so let's proceed to the computation. Okay, so we have oops, let's use the black one or blue one. Okay, the delta a sub I is equal to length times width, and the length is f of x minus g of x times the delta x. Or let's say this is I, x of I, and x of I. And with the use of Riemann sums, we have a sub 1 is equal to, the limit as n approaches infinity of the summation of all the rectangular strips, that's f of x minus g of x sub I, g of x sub I times delta x. I is equal to 1 and n is equal, uh, I is equal to 1 to n. So here, we're now ready to express it in integral notation. So we have, okay, let's go back and review. Again, the upper curve is the f, which is sine x. So sine x minus cosine x dx, and our limits, we have pi over 4, 5 pi over 4. Okay, pi over 4 and 5 pi over 4. Okay, so let's integrate. Now, what's the integral of sine? That's negative cosine x. And what's the integral of cosine? That's sine. Okay, sine x. And we're going to evaluate this from pi over 4 to 5 pi over 4. Okay, so let's integrate this. We have, okay, so we have equals negative cosine. Of course, we're going to start with the upper limit of 5 pi over 4 minus sine 5 pi over 4 minus negative cosine pi over 4 minus sine pi over 4. Okay, so let's simplify. Now, let's go back to the unit circle. What is cosine 5 pi over 4? Okay, cosine 5 pi over 4, 5 pi over 4 is here. So that's negative cosine 5 pi over 4 is equal to cosine. This one is adjacent, so it's negative square root of 2 over 2. And sine 5 pi over 4 is equal to negative square root of 2 over 2. Okay, so let's go back. So first here, it's negative square root of 2 over 2 minus negative square root of 2 over 2. So, and cosine pi over 4 is equal to square root of 2 over 2. So that's negative square root of 2 over 2, right? Minus, what is sine pi over 4? Sine pi over 4 is square root of 2 over 2 as well, right? Okay, sine pi over 4, yeah, correct. Okay, so let's simplify this one. So this becomes negative, positive, positive, so square root of 2 and plus square root of 2. So this becomes square root of 2 plus square root of 2 is 2 square root of 2 square units. Therefore, the sum of, the area of the region bounded by sine and cosine is equal to 2 square root of 2. So therefore, this region, okay, this region is equal to 2 square root of 2 square units. All right, that's it.